Alright, let's tackle the last video on anomaly detection. And basically what we're going to do is we're going to evaluate our coding session. How do we evaluate? Yeah? There's actually a few options. Yeah? One is accuracy. But that's not a great option when you deal with an imbalance like we have, because if you let the machine go its way, the rule it will come out with will be no fraud for all samples. If you calculate the accuracy, it's going to be 99.8%, because it will only make a mistake on the 492 fraud cases. So accuracy is a waste of our time. Yeah? So then we have another metric called the ROC curve and AUC, area under the curve. We've looked at this in the past, and that's actually a great metric. And then we've also seen an F1 score. But here I will not do F1 as well. So I'm going to stick to ROC and AUC. In order to come to ROC curve, which we will draw here, I need to explain again what a confusion matrix is. A confusion matrix is a matrix where you have on top the predictive result versus the actual result. Yeah? For example, if I predict fraud and the transaction is actually fraudulent, then I have a true positive. Okay? When I predict no fraud and the actual is actually no fraud, then I have a true negative. When I predict fraud and the transaction is not fraud, then I have a false positive. And when I predict no fraud and it's actually fraud, I have a false negative. Yeah? So in statistics, false negative is called a type 2 error, and false positive is a type 1 error. And there is a trade-off. If you want to reduce one, you automatically increase the other one. Okay, so let's now take an example. Yeah? And I have an example here where on the x-axis you have your credit card transactions, and on the y-axis you have either fraud or no fraud. It's either 0 or 1. And the curve that will help us is that sigmoid function here. Yeah? So I have 7 points, the crosses are fraudulent, and the circles are no fraud. Yeah? These are just 7 randomly chosen transactions. It's not randomly chosen, because if it would be randomly chosen, actually I would have, a ratio of 99.8% and 0.2%. But don't worry about it. It's just to show the intuition on how we apply confusion matrix to a real issue and how we get to this ROC curve. You see here that the threshold I have in the middle. Yeah. So t is at 0.5. Yeah. And what I'm going to do is now to fill out this confusion matrix for t equals to 0.5. So here in the bottom right corner we have the true positives. Yeah? Here are the positives. Yeah? The points on this side will result in I equal to 1. How many are positive? Well, these 3 crosses here are correct. Yeah? The true positives is 3. Yeah? But here I predict fraud, whereas I have a circle here as no fraud. Yeah? Predict fraud, and it is no fraud. So I have 1 false positive. Now if we go on this side of the T, yeah, here I predict no fraud, and 2 of them are no fraud. Yeah? So true negatives is 2. And automatically I'm going to have 1 false negative, which is this one, Yeah? So this is a false negative, and this is a false positive. Okay? Now, nothing tells us we need to be in the middle with our threshold. We can actually move from 0 to 1. So I'm going to take the two extremes, yeah, and do the confusion matrix again. Let us assume we're now where the threshold is 1, so the t is at the 1 level. In that case, all transactions will be classified as non-fraud. So there will be 0 fraud predictions. Yeah? How many, if I predict no fraud and it is no fraud, so I predict all no fraud, when it is no fraud is in 3 cases, the 3 circles. Yeah? When I predict no fraud and it is actually fraud, these are these 4 crosses. Yeah? So that's for t equals 1. Now t equals 0, yeah, now your t is here. Everything is fraud, right? So your no fraud column is going to be 0. If everything is fraud, these 4 crosses are correct. And you have 3 false positives. Yeah? So let us now, for these 3 cases, calculate the false positive rate. And the false positive rate is false positive divided by false positive plus false negative. And recall which is the true positive rate. Let's take this one here. Yeah? True positive is 3. And true positive plus false negative is 4. So here I have 3 out of 4. For false positives here, I have 1 divided by 1 plus 1. So this is 1 out of 2. Yeah, so this is half here. Yeah, this is half. So in the middle of here, we're basically this point. Yeah, this is for t equals 0.5. Now let us take the situation where t equals 1. When t equals 1, yeah, that means that all your transactions are considered non-fraudulent. What's the impact of that? Well, the bank's gonna miss out on those 492 which were actually fraudulent. Yeah? So it's not ideal for the bank. Yeah? So we take t is 1, we have false positive 0, that means false positive rate is 0, and then on the recall the true positives are 0 as well. Yeah? So we have this point here, and this point means it's all no fraud, right? So the bank has issue. Yeah? So it's not a good strategy. Although from an accuracy point of view, you'll have 99.8%. Let's take a look at this one. In this case, the classifier will classify everything as fraud. Yeah? Imagine we have 285,000 transactions and only 492 were fraud. If you predict all of them fraud, it's just not realistic. And so it's also definitely a point where we do not want to be, yeah? Because you're gonna upset customers. Yeah? If you make a type 1 error, meaning a false positive, that means that you will flag a transaction as fraudulent, which is actually, the transaction is real, is normal. So what are you going to do as a bank? Well, you're going to block the credit card. And what if your customer is just traveling internationally? He cannot use a credit card. Then he's got to call back to the bank and so on. Yeah? So very inconvenient. Type 1 error. A type 2 error is inconvenient for the bank because you miss out on a fraudulent transaction. Yeah? So in the case of t at 0, we have no false negatives, so this will be 1 and this will be 1. So in this case, you have this point. Yeah. Now as a bank, you need to decide what you can live with. You rather have false negatives or you rather have more false positives. That's your decision as a bank, and that will define where your threshold is going to be. So between 0 and 1, you will have, and you know, some kind of curve. This could be like this. Yeah. And the area under the curve is basically the area between the red line and this diagonal. So this is going to be your area under the curve. So basically here in this case you have recall 1, meaning you don't have false negative, which is good for the bank. Yeah? If you want to keep that recall high, you can actually at the same time reduce your false positives as well. But at some point you will actually drop in terms of recall. And as a bank you need to decide how far you're willing to drop. So the ideal curve would be a curve that, you know, that pulls this line right to the left upper corner. Yeah? So that is then a good classifier. If you go something like this, and for the exercise on random forest, gradient boosting machine, and isolation forest, basically you see that your curve is doing like this a little bit. Yeah? So it's actually very good. Okay? So let's now take a look at the results of our algorithms. We had 3 anomaly detection systems and 2 classifiers. Yeah? And what you see is that actually LOF doesn't score very well. 76.7. Your 1-class support vector machine does even worse. And I can tell you it's very slow. I use this one on I think it's a poly kernel with degree 3. I tried linear. And RBF is complex because the machine just keeps going and going and going. Yeah? So it is very slow. Pleasant surprise, iForest was very fast and is pretty good. It's 0.951. But, and here's the big surprise, random forest and gradient boosting machines do actually really well. Which is a little bit counterintuitive because we said we can't use classification algorithms because of the imbalance, so we better use anomaly detection. And now what we see is the classification algorithms are actually doing very well. Especially random forest, which is not only accurate, but it's very fast. Remember, in gradient boosting we have parameters to tune and it will be slower. iForest, which is, you know, a variant of random forest, is also very fast. Yeah. Also good to know is that these 3 top performers are decision trees. These are decision tree classifiers. So it is absolutely no surprise that random forest gradient boosting machines, that these are the top algorithms that we see in Kaggle competition. Remember, this is some kind of what we call ensemble learning, where you take a bunch of weaker classifiers and you make one stronger classifier. So that's an interesting evaluation here. I would say going forward, if you have a classification problem, you know, these 2 or 3 are the way to go. Alright, this was it for anomaly detection. After this we're gonna look at a clustering based algorithm called K-means, and it's also part of unsupervised learning. See you next time.